Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the T-shaped pipe for static structural analysis. We will start by double-clicking on Static Structural module. First, we'll go to Engineering Data and double-click. Engineering Data Sources, General Materials. I'll use stainless steel as one of the material. And the other material is, say, CPVC pipe. I'll give the value of density, which is 1650 kg per meter cube. Also, I'll give the value of isotropic elasticity. The value of Young's modulus is 3.1 gigapascal, so E9. And the value of Poisson's ratio is 0.386. I'll go to project and update project. Next, I'll go to geometry and I will import the geometry of the T pipe. Then I'll go to model and double click. I'll first go to geometry solid. I'll change the material to stainless steel. Next, I'll go to mesh and generate. I'll go to static structural, right click, insert, fix support. I'll choose the face option. This edge I'm going to choose as the face. Next, I'll insert pressure in the internal portions. So I'll select the control button and select. Then right click, insert pressure. I'll give the value of pressure as 0.5 megapascal. I'll go to solution, right click, insert deformation total. I also want to see the strain equivalent and the stress equivalent. I'll go to solution and solve. So this is the total deformation. You can see the maximum value is 0.739 mm. Minimum is 0. If you don't want to see this wireframe, you can go to edges, no wireframe, contour, smooth contour. You can animate and check the result. Next, we'll go to elastic strain. Maximum strain is 0.00115 and minimum is 4.2 into 10 raised to minus 5. You can also animate and check this result. Next is the value of equivalent stress. Highest value is 219.43 megapascal and minimum is 2.8311 megapascal. If you want, you can also animate this, but it won't show anything different than what you have seen in deformation and strain. Now we'll go to solid and change this material to CPVC. We'll go to solution and solve once again. We'll go to total deformation. Here you can see it is 42.38 mm. The reason is this value of pressure which we have given is quite high for this material. If you want, you can change this to say 0.1 megapascal and solve once again, such that you can reduce the value of deformation which is obtained. We'll first go for total deformation. Now you can see this 8.47 mm. 8.47 is also larger, so you can again further reduce this pressure and solve again till you don't get a value which is less enough. Now we will continue with this itself. So if I animate, this is the pattern of its motion. You can see the value of deformation over this T-shaped pipe. Then we go for strain. The highest value is 0.014 Minimum is 0.000519. If you want to see where it is max and where it is min, you can just click on these options. You can see this is maximum, this is minimum. If you don't want to see these values, just click on max min once again. If you use probe, you can see, if you run the probe over this pipe, you can see the value over the entire pipe. You don't want to see it, click on probe once again. Now we'll go to equivalent stress. You can see the maximum stress is 43.08 megapascal. Minimum is 0.618 megapascal. So that's how you can figure out what is the value of stress, deformation, strain. If you want, you can also find out what is the factor of safety. For that, you just have to insert stress tool, maximum stress, and you will get the value of safety factor. Now, I will show you for the material stainless steel, because for CPVC, we again need to give the value of tensile yield strength. So, I'll show you for stainless steel. You must recollect that we have changed the value of pressure. So now the value of deformation and stress strain will also be different. So you can see here, this is the safety factor. The pipe is almost blue in color, which means the pipe is absolutely safe. And in these zones, you can see it is showing green, which means it is between 4.3 to 10. That's how you analyze the T-shaped pipe for its static structure analysis. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.